Give you guys some basic instructions for this next sort of process that you guys have to undergo. Okay, so one of the first instructions that I need you to do, all right, is I need you to select one scheme from the 10 that you already have. So select one design. I better make this bigger so that you guys can see it. How about something like 18. Select one design and add the following. The pool, all right? So you're given an approximate area for a pool, right? So the pool, the concrete deck or whatever other deck is around the pool, okay, and a driveway to your garage. The driveway will be 12 feet wide. Oops, to garage. And then one more thing is the driveway widening at the garage. Okay? So your driveway coming from the street is going to be 12 feet wide going up to the garage. And when it gets to the garage, it's got to get wider because your garage is wider than 12 feet, right? And you got to be able to get two cars in there. You guys know that, right? You guys have driveways at home or wherever. Okay? So those three things, you're going to pick one scheme and you're going to put those three things in it. Okay? Any questions about that? Okay. So the next thing is that you guys are going to be figuring, I'm going to give you some numbers right now. Okay? Or I'm going to give you a number. All right? The percolation rate of the soil for your site is 1/4 inch per hour. All right? So 1/4 of an inch per hour. So I want to make sure that we clarify something. Does grass absorb water when it rains?
Yes.
Yes. Does dirt absorb water when it rains?
Yes.
It does. Does a roof absorb water when it rains? Or wait, let me rephrase that. Is a roof supposed to absorb water when it rains?
No.
No. At my house it does. Okay, good. Does a pool absorb water when it rains?
Yes.
Not exactly. Well, it'll fall in, but eventually it's going to go onto the asphalt. So we're going to assume that a pool is a non-permeable surface. Okay? So permeable, if you recall from the last discussion or the other day's lecture, is permeable means that it absorbs water. So there are surfaces on a site that are permeable and there are surfaces that are impermeable. Okay? So I gave you guys today a calculation sheet. Or we're going to give you a calculation sheet. Okay? And the calculation sheet is a little tricky because there's different things going in different directions on a site when it rains. Okay? So I'll give you a hint. Or no, let me set another parameter. We are going to assume, right, that your building that you've designed, okay, we're going to assume that your building has a 3-foot overhang on the roof. Okay? So whatever footprint you came up with, just assume that the roof overhangs 3 feet all the way around. That simple enough? Do you guys all understand that? So you have to calculate the amount of area that your roof has. And so the very first thing that I want you to do is I want you to decide, is a roof permeable or impermeable? It's impermeable. So if it rains at a rate of 1.5 inches per hour, the roof is going to catch a certain amount of water, right? And it's impermeable, so it's going to capture all of that water. We are going to assume that all of the water captured on the roof during that hour is going to go to a cistern. We are going to assume that the maximum size of the cistern is 4,000 gallons. Now remember, gallons are not cubic feet. So part of what this exercise is about is getting you used to jumping back and forth between units of measure. So you have to figure out, all right, how many cubic feet are in a 4,000 gallon cistern. So you have to do a conversion. Okay? You guys have all picked up a gallon of water? It's smaller than a cubic foot, right? So there's more than 1 gallon of water in a cubic foot. Okay? So, all right. The handout that we are going to give you is going to ask you for the site area in square feet. It is going to ask you for outdoor paved area covered by the roof in square feet. So if part of your pool deck goes under your overhangs, calculate that number. Right? My assumption is that your pool may be near your house, and if you put a deck around it, that when you walk out of the house, you don't step onto dirt, walk 10 paces, and get onto concrete, correct? You step out of your house, and usually you step onto a concrete patio area, and then you walk to the pool. So I don't know. It depends on your design. So I need you to calculate any area of floor that is underneath an overhang. Okay? And then I need you to calculate the amount of outdoor area that is not covered by roof. And I'm going to give you this handout. It'll have all that stuff. Okay? So you've already started doing the volume of water in both cubic feet, cubic inches, but you're also going to be asked for it in gallons. Okay? Don't worry about the cistern size because we're establishing a maximum. So what you guys are going to be doing is figuring out how much water after a 1 hour period at 1.5 inches per hour with a percolation rate of 1/4 of an inch per hour to permeable surfaces will run off of your site and onto the street. Okay? It's tricky. There's a lot of stuff going on here. The water that falls on the roof is going to go to a cistern. If the amount of water that fell on the roof is more than 4,000 gallons, it's going to overflow onto your site. Right? So this is all the logic. Remember I said you like word problems? There it is. Okay? So you guys are going to pick one design for this. All right? And you're going to run through all of these numbers. And you're going to try to figure out how much water is going to come off of your site. Okay? Huh? It's already hurting your head?
Are you going to tell us if we got it right or not?
I can't tell you if you got it right because everybody's design is different. So there's not going to be any one consistent number. I can tell you if the magnitude is in the right area. So, you know, if a generic site that I come up with a generic pool and a generic patio can store 50,000 gallons, right? and you guys come up with a number that says, oh, well, I've got 300,000 gallons, something's wrong. Likewise, if you come up with something that says, well, I only have 3 gallons of overflow water, something's wrong. So it's going to be in the order of magnitude of a standard one.
No, but what about this, what you just gave us right now?
I beg your pardon?
You just gave us the
This is the site.
the
The
little
site.
challenge, the site.
The square foot, square inches, volume of water. The assignment that you just gave us to do right now.
The assignment that I gave you to do is part of this. Right? What's the first thing you started to figure out? The area of your site in square feet. So the very first thing on this list is site area in square feet. Right? So what I did is I released you guys while I was printing this, okay, and deciding on a percolation rate so you could get started on this. Okay?
Are you going to give us a time limit of, as far as the percolation? Because it says per hour, but how many hours?
The following are based on a cloudburst yielding 1.5 inches of rainfall per hour for 1 hour. It's on here. The only thing that's not on here is the percolation rate, which is 1/4 of an inch per hour in permeable areas, not all areas. Okay? So I'll give you a hint. The first thing you got to do is calculate the amount of water that's falling on non-permeable areas. Figure out how much of that water is going to go into a cistern and how much of it's going to flow onto the permeable areas. Okay? You might have to diagram this to kind of figure out, all right, these are the processes. So, all right, is there any questions? This is also going to serve as your homework assignment for next class meeting. Okay? In addition to whatever, did I ask you for something earlier, didn't I? No?
Yes, about the 5 feet.
The what?
You said 3 more of the bottom pieces for the physical.
Yeah, in addition to this, you have adding the 3 additional slices to the bottom of your model so that we can...
He says
3 more though.
I did this in class already once, but I'll do it again. I said there's already 1 there. You're going to add 3 more for a total of 4. Okay, so 4 total. Okay, so that's another piece of homework. Okay, this is not to be taken lightly. So you guys are to take this sheet and you guys are going to have to type it up, right, so that the numbers are legible, and you are going to have to upload it as homework along with your picture of the 4 things by next Tuesday. Okay, so for the scheme that you guys are picking and are working on, I want you to try to design the size of the catchment basin and show it to me on your site. So that'll be 1 more PDF of the site that you guys are going to upload. Okay? Any questions? So you're uploading 3 things. One is a JPEG image of your site with the additional contours, right? You're going to upload a PDF of this, okay? So I can actually make this, I can have Terumi make this available to you guys on Canvas in Word format so you guys can type right on it, okay? And you are going to have to do the design that shows the overhangs, this stuff that's up here on the screen, right? The pool, the concrete deck, the overhangs, the driveway, and all that stuff, taking into consideration the percolation rate, etc., that shows the size of the catchment basin at the bottom. Okay? All right, questions? And I got to stop this video because it's going to get too long, so I'm going to pause it. I'm going to add in here that the maximum depth for the water catchment basin, I'm going to set it at 7 feet, okay?
But if we...
So max depth of catchment basin, 7 feet. All right, I'll see you guys all on Tuesday. This has to be uploaded by 4 o'clock on the day of class.